Hello again, physics friends. Today in this video we're going to talk about the light year and other similar and convenient units of distance. Right. So far we've talked about length, and we've typically used feet or meters or miles and so on. But in this class we're often talking about objects moving at or near the speed of light. And so another convenient unit for distance is to talk about distance in terms of speed of light, right? So here's, maybe it's just easiest to think about it with an example. So we know that it takes 8 minutes for light to go from the sun to the earth. It's about 8 minutes. So if we had a photon here, and that was the initial time, and then sometime later that photon is now at the earth. Right? If we know that that trip takes a time of, say, 8 minutes, and we know that this photon is traveling at the speed of light, we also know that the distance traveled is equal to the speed times the elapsed time. Okay, and the speed here is c, and the elapsed time is 8 minutes. Right, and we could put in, 3 times 10 to the 8th meters per second for c, and then convert minutes to seconds, and then we could write the distance in meters. But why not just leave it in these units? 8 minutes times c. Another way we talk about this is we say it's 8 light minutes, which is a measure of distance, and it's the distance light travels in 8 minutes. It's actually quite convenient to think about it this way, and our unit will be min times c, or minutes times the speed of light. So for example, let's say that we, instead of having a photon make this journey, let's say that we were in a rocket ship, and we're going to make this journey. Okay, so we might start our journey here. Okay, sometime later we won't quite have made it from the sun to the earth because light is traveling faster than our ship. Okay, and let's say, just for fun, that let's say it takes the rocket, eventually the rocket does get there, and let's say it takes the rocket, how about 20 minutes? 20 minutes. To go from the sun to the earth. And this is as measured in the sun's frame. Okay, one question we could ask if we were given that information is, what is the speed of the rocket? Again, in the sun frame. Okay. All right, well, we can approach this by, we know that distance is speed times time. So if we're trying to solve for speed, we could write that as a distance traveled divided by elapsed time. Okay, and here now we know that the distance between the sun and the earth is 8 light minutes. Okay, so we can just say 8 light minutes, or 8 min c, divided by the elapsed time of 20 min. And now the mins cancel, and we're left with 8 over 20, okay, which is what? 2/4, what? No, it's not 1/2. If we divide the top by 4, we get 2. If we divide the bottom by 4, we get 5. So this would be 2/5 c. In other words, we could just leave it at 2/5 c, or we could also say 2/5 of a foot per nanosecond. And that's the speed of the rocket in the sun's frame. So it's convenient. We never had to do anything with meters or seconds. The units of the problem are kind of convenient because all of the travel times are in minutes and the distance are in light minutes. Okay. As another example, if we considered two objects that were even further away, we could have the sun and some distant star, and let's say it took light 4 years to make this trip from the sun to the star. So if we have, again, our photon here, it's traveling at C, and we put a clock on the sun and a clock on the star. At the launch of the photon, those clocks both read 0, and then sometime later in the sun frame, we still have the sun in the same place, and we still have the star in the same place in this frame, but now this photon has arrived, and 4 years has elapsed in this frame. We could say the distance between the distance from the sun to star is equal to the speed of the object traveling times the elapsed time. And the object that's traveling is light, so its speed is c, the elapsed time is 4 years. And when we multiply these out, we can just leave it as 4 years times c, and this collective quantity, which is representing a distance, is called a light year. Okay. And again, if we had a rocket, let's say we had a rocket traveling at half the speed of light, we could ask how long does it take for that rocket to make the trip. So a rocket with velocity equal to half c, how long would that take to make the trip in the sun's frame? Well, the elapsed time is going to be equal to the distance divided by the speed. And the distance we said was 4 light years. And the speed we said was 1/2 c. The c's cancel, and we're left with years as our unit, and 4 divided by 1/2 is 2. So it would take 8 years for a rocket traveling at half the speed of light to go from the sun to this distant star. So this unit of light year or light minute or light second or light month, whatever it is a very convenient unit in relativity for the reasons that we've just seen. It makes the calculations easier. You often see that the c will cancel in the calculation, or that years will cancel. That either the time piece or the speed piece will cancel when making the calculation, and you're left with an easy result that's straightforward to calculate. Okay, well, this was just a quick video to introduce this idea of using light minutes, light seconds, light years, and so on as a distance measurement convenient for relativity. Take care, and all the best.